This graph from Desmos represents the problem. This blue curve here, which has a purple top, is the graph of x equals y squared, which I've also written as y equals the square root of x, which is just this branch of that curve. The red graph is y equals x squared. I'll leave it to you to find the points of intersection. And this green line is the line y equals -6, which is the axis of revolution. It looks like this integral solves the problem. And here's an exact answer, 43 pi over 10. The same answer for both. The question is, where did I get this integral? And the volume of revolution using the washer method requires a typical rectangle to be perpendicular to the axis of revolution. That's what this black line represents, a typical radius or a typical rectangle along the interval from 0 to 1 along the x-axis. The outer radius is the distance from the top to the axis of revolution. Well, for any x coordinate in the interval from 0 to 1, this y value right here is the square root of x. That's the y coordinate. And the distance from here down to the axis of revolution is the square root of x minus a -6, top minus bottom, which is square root of x plus 6. And there's the outer radius squared, which is what this is right here. And the inner radius is the distance from this point along the curve y equals x squared, which has a y coordinate of x squared. So the inner radius is the distance from here down to here. That's x squared, top minus bottom again. X squared minus a -6 is x squared plus 6. And there's the inner radius squared. And so the volume of revolution is given by pi, definite integral from 0 to 1 of outer radius squared minus inner radius squared. Now, what do you get when you square this first radius? You're squaring a binomial. I'm not going to take us through the whole thing, but the first term squared is x plus double the product of the two terms. And instead of writing the square root of x, I'll write it as x to the 1/2. And then square the second term plus 36. And from that, we are going to subtract the inner radius squared, which will be x to the 4th plus 12x squared plus 36. And when you actually subtract and combine similar terms, you get x plus 12x to the 1/2 36 minus 36. 36's cancel out. We'll get minus x to the 4th minus 12x squared. That's kind of what I've done on scrap paper here, is figure out what this mess simplifies to. And now we want to find an antiderivative of that, so we raise each exponent by 1 and multiply it by the reciprocal of the new exponent. So the antiderivative will be 1/2 x squared. Raise the exponent by 1, we get x to the 3/2. Multiply by the reciprocal of the new exponent. So 12 times 2/3 is 8 minus 1/5 x to the 5th and minus 4x to the 3rd. So there's the antiderivative evaluated from 0 to 1. Excuse me. And of course, that result we still have that pi out front. If you substitute 1 in for x, you get 1/2 plus 8 minus 1/5 minus 4. Convert every one of those terms to tenths, because that's the common denominator for the 2 and the 5. If you put 0 in for x, all those terms will evaluate to 0. You should get 43 pi over 10.